In this lesson, we are working on standard 4.OA.4. And in this section, because it is a large standard, we are focusing on factor pairs using the divisibility rules. And using the divisibility rules is an important skill to master factor pairs. So let's move right in and look at those first. So here's just a little snapshot of what those divisibility rules are. If you see this, it tells you that a number is divisible by 2 if the last digit is even. So I always tell students that every even number, except for the number 2, of course, is going to be a composite number, because again, knowing factor pairs leads you to understanding prime and composite, which will come up in a different video segment. So every even number has 2 as a factor. And every number, if you add up the sum of the digits, if they add up to be a multiple of 3, then it is divisible by 3. Define if a number is divisible by 4. If the last 2 numbers form a digit that's divisible by 4, then it is divisible by 4. If the number ends with, if the last digit is a 5 or a 0, it's divisible by 5. If the number is divisible by both 2 and 3, then it's divisible by 6. And 7's quite a jump. It's more of a long division sort of check, but as you see, you can double the last digit and subtract the sum from the rest of the numbers to the left of the ones place, and the answer is 0, or divisible by 7. It's divisible by 8 if the last 3 digits form a number divisible by 8. And a number is divisible by 9 if the sum of all the digits is divisible by 9. And it's divisible by 10, of course, if it ends with a 0. Okay, so let's talk about factor pairs. Okay, so if we, let's do an example. Let's just do the number 24. Okay, let's try it with the number 24. So if I have 24, we'll do our little t-chart here. We know that 1 is a factor of every number, so I know the factor pair, of course, is always 1 and itself, so 1 and 24. And 24 is indeed an even number, so I know that 2 would be a factor. And to find out the matching factor pair, of course, you could do your whatever the multiple number is that you're working on and divide it by that matching factor. And of course, if I did 24 divided by 2, I would see 12. Okay, and also to see if it is divisible by 3, that is where I add up the 2 digits to see if it creates a multiple of 3. So if I add up my 2 digits, 2 plus 4, I see that would total up to be 6, and 6 is a multiple of 3. So I know that 3 is a factor. And I know that matching factor pair is 8. Okay, and if I think about the factor 4, that rule for 4 is if the last 2 numbers form a digit that's divisible by 4, then 4 is a factor. So we only have 2 digits, of course, but so it's a little bit more difficult. But if I know that if I know that 2 is a factor of a number, that I also should check to see if 4 is a factor. So in this case, 4 is a factor of 24, so that would be 4 and 6 would be the factor pair. And I know that 5 is not a factor because it does not end with a 0 or a 5. And as for 6, if both 2 and 3 are factors of that number, then 6 is also a factor. And so we do have 2 and 3, but we see we already have our factor 6 here, along with the 4. And 7 is not a factor. And 8, if the last 3 digits form a number that's divisible by 8, but we don't have a 3-digit number here. But I do know that 8 is already a factor. It goes with our multiple 3, or factor 3. And I'm going to check all the way up to 10, but I know that 9 is not a factor because it says if the sum of all the digits is divisible by 9. So that is not the case with 2 and 4. And it does not end with a 0, so 10 is not a factor. So there will be my factor pairs for 24. 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Let's do 48. Okay, so again, I know that 1 in itself is always a factor pair. And again, this is an even number. Every even number has 2 as a factor. So it would be 2 times 24. Again, if you're not sure what that matching factor is, you take your number that you're working on the factors of, and you divide it by that factor that you do know is present. Okay, and so for 3, if the sum of the digits adds up to be a multiple of 3, so if I added up these two digits, 4 plus 8 is 12, so I know that 12 is a multiple of 3. If I skip count by 3s, 3, 6, 9, 12. I know that 3 would be a factor. And again, if I don't know that matching factor pair, I could do division, but I do know that it's 16. Okay, and as for 4, I see that the last two digits are divisible by 4. Okay, so 4 is going to be a factor. So, and that matching factor is 12. Again, you can do division if you're not sure. And 5 is not a factor because it does not end with a 5 or a 0. 6 is a factor because it has 2 and 3 as factors. So if 2 and 3 are factors of a number, 6 must be a factor. In this case, the pair is 6 times 8. And I can check 7. And 7 is not a factor of 48. And we have 8. And 9 is not a factor because the sum of the digits is not divisible by 9. 12 is not divisible by 9. And 10 is not a factor because it does not end with a 0. So hopefully some practice using divisibility rules and doing a couple examples of finding factor pairs is helpful. And it's a little bit more difficult for students to try to comprehend when it's a prime number and composite number. But we'll lead into that in a little separate video. But hopefully this was helpful to you in helping your child work on factor